And lovely to see you all here today. Niamh Shaw is my name, and I am hosting this morning's session, which of course we know is the ESERO Ireland Space Careers Roadshow, and it's a special one to celebrate Space Week. And we have a terrific lineup of people for you to hear about this morning who are going to share how they got to where they are in their careers so far, because the theme this year for Space Week is, of course, women in space. So they are three terrific women, and we're going to be hearing from them very shortly. Firstly, I'm going to hand you over to the awesome Stephanie O'Neill, who runs ESERO Ireland and is behind it all. And then I will briefly say hello to everybody that's going to be joining us this morning. Good morning, Stephanie. How are you?
Morning.
And where are you?
Good, thanks. I'm in Dull, Kildare, Plain, County Kildare.
Dull.
But I think the sun will come out later. It's been nice for the last couple of days, but yeah, it's great.
Lovely.
Can you see my slides, Niamh?
No, I think, no, share your screen. I just see you. So you should share your screen again, and we'll get going. And you're going to meet some amazing people this morning. There are prizes and everything, but let's hear from Stephanie first, and I'll break down the morning for you afterwards.
No, is that working now?
Yeah, it's lovely.
Okay, brilliant. So good morning, everyone, and welcome to our Space Careers Roadshow. We have a series of roadshows every year. We usually do one for Engineers Week in the spring, and then a Space Week event, which this one is, of course, even though Space Week was last week, and then a Science Week roadshow. So that's the next one coming up, and do watch out for that on the ESERO Ireland website. So the roadshows are an opportunity for you to meet scientists and engineers in the space sector and to hear about their STEM education and their career experience to date. And this is a chance for you to see some of the opportunities that are out there for you. So that's what we're trying to do, bring you a broad range of different types of speakers so that you can see the opportunities that are actually there for you as young people in second level today. I also want to thank my colleagues in BCO who manage this event on behalf of ESERO. So there's Rob, Danielle and Alan, and they're in and out and in the background and doing a stellar job today, moving everybody from the main room to the breakout rooms and making sure that everybody is where they want to be, and moderating the breakout rooms. So there will be a bit of moving around as we go through the morning. Of course, I've mentioned Space Week. And that's the 4th to the 10th of October every year. In Ireland, it's managed by Blackrock Castle Observatory. It's part of World Space Week, of course, which takes place from the same event. So there's thousands of events happening all over the world, but we have hundreds of events which happened last week and are continuing to happen this week. Big thing, I suppose, big message is to watch the spaceweek.ie website. Get involved. You can still get involved this week, even if you didn't maybe do something last week. Make sure to get involved, and if you are running an event, to put it up on the Space Week website. I also want to mention Smart Futures. Smart Futures is the SFI Careers campaign promoting STEM careers. So everything that we do, I suppose, is in conjunction with the SFI Smart Futures program. So I don't know if you've heard about Creating Our Future yet. There is a roadshow ongoing. There's a lot of advertising going on about it at the moment. And what it is a government initiative to spark a national conversation about research in Ireland. SFI, or Science Foundation, is one of the partners, and that's where I'm based. I work in Science Foundation Ireland in the Education and Public Engagement Department. And we want you to tell us your idea for what researchers in Ireland should explore to create a better future and to make Ireland a better place to live. So we have some suggestions for how you can get involved, and we will be talking about this throughout the morning and particularly in the breakout rooms. So Science Week, as you probably know, is coming up as well. And there are some Science Week toolkits that you can use in your classes in the lead up to Science Week to discuss STEM topics in your class and how those STEM topics might affect your future. You could visit the Creating Our Future Roadshow and have a chat with the team there. We're bringing researchers from different organizations out on the road with the roadshow. And that's out, I think it's up in the northwest this week. It was in Galway and Castlebar yesterday. And I think we'll be going to Donegal somewhere in the, actually, I don't know where it is today, but you'll get that on the Creating Our Future website, creatingourfuture.ie. So if you have a chance to go out and talk to some of the researchers, that would be fantastic. Use the inspiration of the Creating Our Future website to come up with an idea or help to plan an event to come up with ideas. So there's different tools and techniques on the website and different ideas to give you tips on maybe the topics for discussion. And then finally is to make sure to submit any ideas that you have about what you feel should be researched on the Creating Our Future website. And it could be anything. It could be something that you're passionate about. It could be in the environment. It could be the climate. It could be maybe you have a sick relative and you want research done into that disease or illness. So have a think about that. Listen to what's going on during the day and make sure to submit any ideas that you have on the Creating Our Future website. So back to today. So we have a very exciting morning lined up to you, some fantastic speakers. That's just the layout of today. I'm on now, due to be finished at 10, but we started a little bit late, so please bear with me. We'll then move on to the speakers, Maria, Ashlyn and Prashati. And after each speaker, there'll be an opportunity. So when Maria finishes speaking, she'll move into a breakout room with some of the schools, and the remainder schools will stay with Ashlyn and so on. So there'll be some people going to each of the breakout rooms for a chance to have more in-depth conversation with each of the speakers. Then we'll have a discussion about telescopes and what people in different organizations are doing with their telescopes and how they're working and what they're being used for. So there's some research opportunities there. We'll have a Q&A with the panel then. We'll collate the questions that you're going to be asking during the breakout rooms and the Q&A session, and we'll select a winner then for the prize. I think there's a prize for the best question, and there's a prize for going to the class as well. Just in terms of the speakers, I want to sincerely thank our speakers for giving their time today. Dr. Prashati Patel is an astrophysicist and a science communicator, and she's joining us from Canada today. It's just 5 o'clock in the morning, so thank you so much for getting up so early. And she's going to tell us about, she's actually seconded to the Canadian Space Agency at the moment. She's going to tell us about her work there and other work that she's been involved in. Ashlyn Shannon, and you may guess by the name, that she's Irish, is a structural engineer at the European Space Agency, and she's joining us from ESTEC in the Netherlands. And Dr. Maria Lyubanova joins us from the European Southern Observatory headquarters in Germany. So Ireland is recently joined the European Southern Observatory. So I'm really excited to hear about her work and how it can affect us here in Ireland. We're really thrilled to have these three exceptional women with us today to share their experience, and not least because the theme for Space Week this year is Women in Space. So thank you, ladies, for joining us. I'm really looking forward to what you have to say. Actually, I was ahead of myself on the slide. That's a slide from the last one that I forgot to delete. Apologies. So I need to tell you a little bit about ESERO, which is where I work. I run the European Space Education Resource Office, and that's a contract between the European Space Agency Education Office and Science Foundation in Ireland. There's a network of 18 ESEROs across Europe. As I say, in Ireland, it's a contract between the European Space Agency and Science Foundation Ireland. In each of the other 17 ESEROs, contract between different organisations. For example, in the UK, the contract is with the National STEM Centre in York. In the Netherlands, it's a contract between the Neuroscience Museum. So it's different organisation hosting ESERO in each of the countries. And what we do is that we take resources and projects that are developed for across Europe, and we adapt them to be delivered in the national countries. So things are kind of run slightly differently. Our classroom resources are adapted to suit the national needs in each country. The ESERO objectives are to use space as a context to enhance the literacy and competence of young people in STEM, to motivate and enable young Europeans to pursue a career in STEM, and particularly in the space domain, and to increase the young people's awareness of the importance of space research, exploration, and the applications of these in the modern societies and economies. So you can see that this event today really drives the ESERO initiatives, and it's one of the many things that we have to try and meet the objectives of the ESERO offices. Something else I wanted to tell you about is the Esa School Projects that are run every year. And these are projects and competitions that are run across Europe, promoted and organised in each of the countries by the ESEROs, but run internationally by the European Space Agency. CANSAT we're well familiar with here in Ireland. It's a competition where teams transition year and up are given a kit, an Arduino kit, and they have to build a satellite and launch a satellite. AstroPi is relatively new, but we have been running it for a couple of years now in Ireland. It's about programming. There's 2 levels, and students write code, and the code is run on the International Space Station. Climate Detectives, we ran it here last year in Ireland, and we're hoping that this will take off more this year. This is a really exciting project and really timely. It's where students have to identify a climate problem in their country. They've got to use data to confirm or deny there's a problem. And I think this is the real beauty of the project, is actually the use of data, because that's, after all, what scientists do in their lives, is they're working with data all the time to either confirm or deny. And then students come up with some mitigating ideas for how to help with the climate change problem that they've identified. MoonCamp is definitely the newest one for us. That's about using technology. It's about linking with the technology subjects, and it's about designing a habitat on the moon. So that's one we will be getting involved more and more in the future. And just because ESERO doesn't do it doesn't mean that you can't get involved. You can still work directly on that project if that's something that interests you. I talked about ESERO, and I really want to show you the esero.ie website, because this is where all the information is brought together. Everything that we do is always on the website, and that's where you'll find everything, all the projects. So there, for example, under projects, we have AstroPi, CANSAT, Climate Detectives, and they're the ones that we run in Ireland. So for all that information about the projects, go to esero.ie. Another thing I want to tell you about is the ESA Teach with Space classroom resources. This is probably more relevant for the teachers in the audience today, but no reason that the students can't engage with these as well. And these are a huge bank of resources themed with or branded with Teach with Space. They're broken down into primary and secondary. And there's just some of the secondary resources that are available to schools for use in their science classes. And then I just quickly to mention that the teacher support area on the esero.ie website. We've just finished our big annual conference, which took place last Saturday. It's called the Space Education Conference. And again, for teachers, any teacher support, any CPD that we're offering will be always on the website. In terms of social media, the main platform that we use is Twitter. So please follow us at esero_IE. Please follow us, and that way you'll find out about everything that we offer, because we promote mainly using the Twitter platform. Stephanie.O'Neill@sfi.ie is my email address. That's there now. Happy to hear from any of you. Unfortunately, I can't engage with students under 18 because of GDPR and child safeguarding rules. But if any of the teachers want to contact me, I'm happy to engage with you if you have any questions. I mentioned a few times the European Space Agency. Ireland is a member of the European Space Agency. I know that everyone always knows about NASA and the work that they do, because they're so good at promoting themselves. And I suppose there's the historic reason and everything there. But we actually have a European Space Agency. Ireland is a member of that European Space Agency, and there are some amazing missions that ESA are involved with on their own and both in partnership. So I did want to share a short video with you this morning. It's about 4 minutes, and it does actually explain the work that the European Space Agency does. And I hope that you get a real feel for it. It's really important that we realise that we have our own European Space Agency. We have our own European astronauts, and there's fantastic work going on. So I'm just going to show that briefly now.
This is the European Space Agency, dedicated to the peaceful exploration and use of space for the benefit of humankind. Established in 1975, we work together with our 22 member states to push the frontiers of science and technology and promote economic growth in Europe. We have offices in 8 locations across Europe and 1 at Europe's Spaceport in French Guiana, where we provide independent access to space for scientific and commercial missions. Exploring space is humankind's greatest adventure and one that we have been involved with for more than 40 years. ESA has the technology and expertise to keep Europe at the heart of the new age of space exploration. From low Earth orbit, we are working to bring humans back to the moon and then onto Mars. By expanding the frontiers of knowledge, we are helping to answer the big questions about the universe. Space provides us with incredible opportunities to experiment and discover, yielding amazing new science. From Earth's neighbors to new worlds, we study stars, galaxies, and look for exoplanets. In addition to astronomy, planetary science, and astrophysics, ESA scientists work on growing food in space, searching for life on Mars, and understanding our own planet. From space, satellites are watching over Earth to monitor its health. Our satellites improve weather forecasts, observe the long-term effects of climate change, and contribute valuable knowledge to Earth science. The Sentinel satellites for the European Copernicus program provide vital information on our environment that can help improve our daily lives. Satellites also help you find where you are and get you where you want to go. We have developed Galileo, Europe's own global satellite system for navigating the globe. With over 20 satellites and a network of ground stations, Galileo provides precise global positioning information. Satellites are also connecting the world, making possible many of the technologies we use every day, like satellite TV and internet access. ESA is at the heart of Europe's satellite communications, developing new telecommunication systems and nurturing European innovation, bringing industry, science, and space technology together. In order to achieve all this, we need pioneering technologies that push the boundaries of the possible. ESA's world-class laboratories turn science into innovation, developing hardware and software for use in space and on the ground. Space technology gets rigorously tested to ensure it can withstand the harsh environment of space and the journey to get there. Traveling to space reliably is at the heart of ESA's vision for space transportation. We launch rockets that carry satellites into orbit and are constantly improving the design of our next generation of launchers, Ariane 6 and Vega C. These rockets and the reusable Space Rider will ensure that Europe continues to have autonomous and affordable access to space. Once in space, mission controllers are operating spacecraft around the clock to watch our planet, study the universe, and explore the solar system. We've flown more than 80 missions, including Rosetta, which landed Philae on Comet 67P, and Huygens, which touched down on Saturn's moon. We operate a worldwide network of ground stations to keep in contact with missions anywhere. ESA is dedicated to making space safer. Our teams help spacecraft to avoid collisions with space debris, and we are developing new techniques to deorbit dead satellites. We bring high-tech telescopes to scan the night sky for asteroids and missions to monitor our sun. With these technologies, early warnings can be delivered about potential asteroid impacts or hazardous solar activity that can affect infrastructure on Earth. ESA's diverse activities are all part of a clear vision for Europe in space. Space is the future.
Yeah.
We are all part of it. This is ESA.
So that's it. I mean, I think that gives a really good sense of the really diverse work and the really important work that's actually going on in our European Space Agency. Much better than I could talk about it. So now I'll hand you back to Niamh. Niamh Shaw, our MC for the day. Of course, I didn't thank her at the beginning. I may not get a chance at the end. So thanks as always, Niamh. She does a fantastic job for these events and for other events for us. She's so knowledgeable about space and STEM and is able to bring it all together in a really nice way. So over to you, Niamh.
Thanks, Stephanie. Thanks very much. If you just unshare your screen there, Stephanie, we'll get cracking. That's brilliant. Like Niamh, I'm Niamh. I'm hosting today. I think Stephanie has said everything else that needs to be said. And we can kind of just get cracking on into it, because the more we can hear from our three speakers, the more use you can make of today. Don't forget, there is a prize for the best question. So keep listening and keep having your questions there in the back of your head. There'll be a Q&A session just at the very end. And the best question will win an amazing goodie bag of space goodies, an Esa hoodie and lots of notebooks and loads of really great things in there. So Maria, let's talk to Maria. Maria Lubanova. Stephanie's already told us that she's head of media relations at ESO, which is the European Southern Observatory, of which we are a member. And Maria, you're talking to us today from Munich in Germany, I hear. What's the weather like where you are?
Annie, I'm very nice to see you and to be connected with your lovely country today. Well, it's a pretty gray and dull weather today. The perfect time to spend, to be home and spend some time with people around the globe.
Great, good. So without further ado, let's hear a little bit about your career, Maria. And I think you've got some slides there, so you should be able to share them. If not, let me know and we'll make sure you've got screen sharing options. So we're going to be hearing from Maria for the next 20 minutes, and then she'll move into a breakout session for a further 20 minutes for you to be able to ask her questions one-to-one. So Maria, over to you.
Thanks, Niamh. Do you see my slide at the moment?
Yeah, I can see it. It's lovely, loud and clear.
Thank you. The usual checks. So very nice. I'm very happy to meet all the participants of this call today. I'm Maria, and I'm an astronomer by vocation and by heart and by profession. And I think I'm particularly lucky in that respect that I've managed to achieve that kind of childhood dream of mine. So I am, as Niamh mentioned, an astronomer at the European Southern Observatory, and my research interests are in the area of black holes and star clusters, which are living in the nuclei of galaxies, these massive stellar agglomerates in the universe, just like our Milky Way galaxy. And also other things that I'm interested is how dark matter and bright matter, so the stars and everything that we see around us, interact, and how we learn from each and the other. Part of my work also involves a lot of student mentoring and supervision, which I totally enjoy because I find this a very rewarding experience to transfer my knowledge to the next generation of scientists, engineers, entrepreneurs, and many other ideas that young people have. As an astronomer at the European Southern Observatory, I have up to half of my time goes for working directly supporting the observatory. And a part of my research there, and my functional role is for the Department of Communications, where I'm a scientific advisor and head of the media relations team and editor of the ESO Science and Technology Journal. Here you can see what does it mean to be a science advisor of a Department of Communication. This means that I interact very often with our science writers, science visualizations artists to create scientifically accurate representations of what the ESO astronomers community around the globe has discovered. And here you can see such an artist's impression of an exploding kilonova. So two neutron stars have been merging and creating this massive blast. And this was one of the first items that I was science advisor for, to create this science visualization. You see the ripples of the gravitational waves going away to the side. What else do I do? So I'm a parent of a 10-year-old daughter, which you see here in the upper right corner, who is a very avid mountaineer and fossil hunter. So I have been trying to lure her into the exploration of space, but for her, exploring the ground, has been much more important. So I really enjoy studying about the history of Earth together with her. And here you can see us in the left looking at something which might or might not be a fossil. We don't know yet. We are still on the track. And I love a lot exploring nature and wild camping, which I get to do in my home country every summer. How did it all begin that I became an astronomer at all? As a kid, I've been naturally interested in the sky and the stars, but my most vivid memories of getting interested about astronomy, this was in 1997, so when I was around 16 years old, when I did not see this comet. And you might wonder, how did I become an astronomer if I didn't see it? Well, the question was, why didn't I see it? I was so bothered by that. I've read in a newspaper that the comet Hale-Bopp, which will be the massive show of the decade, will be visible on this and that date on the night sky. I remember it in March or April, so it was spring, and I went out in my hometown in Sofia, Bulgaria, to look through the window, and I did not see any comet. The sky was not cloudy, there were stars, but I did not see the comet. And it's like that my parents didn't know what was happening, they couldn't explain me, so I was like, really, why didn't I see this comet? And it was really, really bothering me. So then I started exploring further, trying to find resources, to try to read more, and in magazines to understand what is happening, why I didn't see this comet. And I've been a bit fortunate growing up in part of Europe, which is not very light polluted. So here you see a map of the light pollution in Europe as seen from space. And here in the left corner on your screen, you see Ireland, which is with the bright red spots of the big cities. And this is which shows more and more light pollution. And Central Europe, you see it's everywhere. The night sky is really bright. I've had the opportunity to grow in the southeast part of Europe, where there is not so much light pollution, even though I grew up exactly at the brightest spot in Bulgaria. So this is the capital, Sofia. However, I've had access to very pristine sky at the village where my father is born. So I've been spending there the summer vacations, really contemplating the night sky. And through my high school years, I started being more interested into astronomy, reading more and more. I had a fantastic teacher, which was a physics teacher, who was answering all kinds of questions which I had. And I'm really, I really appreciate her approach to that, because she didn't push me away to say, oh, this you're going to study when you be in 10th or 11th class. She was just basically answering my questions when I had them. How did it all continue? Well, 99 came, and there was this massive solar eclipse crossing the parts of Central Europe. And in Bulgaria, here in the right corner of this map, you can see the totality part. It was crossing also my small, beautiful country, but I did not get to see it either. So another note, this one also has an interesting story why I didn't get to see it, mainly because how this could be that a girl would be interested in astronomy. So at that time, being already 18 years old, quite interested in astronomy and in physics, and wanting to study that at university, and quite a lot of society around me, family including, were like, why do you want to waste your life doing physics? Why don't you do something that would be more profitable, that would give you a good career? Why don't you become a journalist or a translator or something different? Well, I did see the solar eclipse with a very partial part of the solar eclipse. I even managed to make a picture. Unfortunately, couldn't find yesterday the picture in my home, so I will really need to try and look for it. But this is another missed opportunity that really made me convinced that this is actually what I really want to do, and I really want to explore the space. And so the next step for me was really moving from an amateur astronomer to science communicator. So I got in touch with the Astronomical Association in Sofia, which is a non-governmental organization with the goal to promote astronomy in Bulgaria, which is still existing, and publishes a magazine for astronomy. Here you see on the right-hand side, and a newspaper for astronomy, which in 1999 was the first newspaper around the world about astronomy. So I became an author and editor later of these two publications. And here you can see the covers of these magazines, the two covers to the right that I've shared. I'm very proud of them. These are two of my very first materials that I've prepared for the newspaper, which were for the magazine, which were put on the cover. So one is about the theory of the Big Bang theory and the birth of the universe, and the other one about the satellites of Jupiter, and specifically the very interesting life of Io. So I've always found very satisfying to be a science communicator, and I've been doing it throughout my life as an astronomer, although at different target audiences. Early on, it was a lot of sidewalk astronomy, taking with my friends telescopes of the Astronomical Association Sofia to the city squares of Sofia and showing people the excitement of the night sky. Later on at university, convincing my colleagues that they should really pursue astronomy. And later on nowadays with supervising students, as well as in my current work, again, as a professional science communicator. So after finishing my high school studies, I went to study physics and astronomy at the University of Sofia in Bulgaria. Here to the left, you see the majestic building of the rectorate, the main building. And to the right, it's our very tiny observatory in Sofia, which is a historical building. And it has inside of it this 6-inch telescope built in 1897, which nowadays it's used mainly for demonstrations. This telescope has an interesting Irish history because it's made by the company originally founded in Dublin by Thomas Group, which later on turned to a more grown-up, a bigger company, which was famous all the way until the 1980s around Europe, providing very high-quality instruments. So the telescope in Sofia Observatory is very similar to the ones that are in the Dunsky Observatory, if I pronounce this correctly, produced by the same producer. And after finishing physics, so my astropath continued westward. So my biggest move in kilometers wide was to start my PhD studies in Munich, in Germany, at the headquarters of the European Southern Observatory. This I've done for about 3.5 years. And then I've moved on for my next stage of career path, my postdoctoral research in Heidelberg in Germany, in the Max Planck Institute for Astronomy. Later on, I've moved at the University of Groningen, the Netherlands. Really amazing skies I've been witnessing in the Netherlands. Groningen is located in the northern part of the Netherlands, and the skies are really clear. So that's something that I've always enjoyed there, though didn't manage to see the northern lights. And then since 2017, I moved back to Munich, where I've started my current job at the European Southern Observatory. Brief note what the European Southern Observatory is. This is an intergovernmental organization with 16 member states. Ireland is our most recent member state, as Niam and Stephanie already mentioned, since 2018. And all the telescopes that the European Southern Observatory builds are located in Chile, in the Southern Hemisphere. This was one of the missions that the observatory was created to explore the southern sky. Why the southern sky? First, because it was not explored, and second, because the sky is very clear. Here you can see a picture from space made from the Hubble Space Telescope. To your left corner of the picture, that's what you see. And it's a picture of South America. And you see that what you see there is the driest place on Earth, the Atacama Desert. And you can see the clouds over the Pacific Oceans are really stopped. And this is a very interesting phenomenon due to the Hubble stream, that the Atacama Desert is really, really dry throughout the year. And you can see the locations of two of the observatories of ESO. The main one that I totally love and I always appreciate visiting, this is the home of the very, very large telescope, the current flagship of the European Southern Observatory, consisting of 4 telescopes, each one with diameter of 8 meters, and also a multitude of other smaller ones which can get connected. Here you can see me on the platform of this of the VLT, surrounded by these giant domes, and they're really giant. So in each of these, there is the telescope with 8.2 meters. And here you can see me in the dome of one of them. The mirror, this 8.2 meters mirror is sitting here on top of the white platform, which is maintaining its shape continuously. And what I'm pointing at is my favorite instrument called Symphony. This is the instrument with which I did majority of my research for my PhD, and also using it until nowadays. The data from it, the instrument was decommissioned. Now it is being refurbished to become more powerful. But I see something that I will always stay deeply in love with that instrument, because it is a really powerful machine to decipher the secrets of the universe. My job has brought me also to other exciting places. This is a place which I will always fondly remember, the ALMA Observatory at 5,000 meters above sea level. I'm very proud that one of the highest places on Earth that I've been by myself, like with my feet, is climbing one of these antennas. So while I'm saying breathless science, at 5,000 meters, there is not a lot of oxygen. So it's quite complicated to breathe. What I'm having here, my right hand, is tank with oxygen. So when I visited ALMA on that day, you see a lot of clouds and it's very mystic environment. However, this is a very, very rare sight there. Because this observatory is built so high to allow radio telescopes to observe the sky without being prevented by the water vapor in the atmosphere. So typically there are more than 300 very dry days and nights on ALMA that the telescope can keep on observing. And here you can see telescopes are not working. They're all pointing to one direction. There is way too much water vapor in the atmosphere. A place that I am looking forward to visit, this is the next big project that ESO is building. So this is the ESO's extremely large telescope. This is with a planned first light in 2027. This will be a very gigantic telescope, the largest optical telescope that humanity has built so far. It will have a mirror of diameter 39.2 meters. It's not going to be one single mirror because it's impossible to build such a big mirror, but it will be made out of almost 700 smaller segments that are going to get together to all the time in a perfect shape to see the universe. So plan first light in 2027. And so I have been there actually. So perhaps you might remember this very first picture that I've showed on my opening slides. This is me being there climbing one of the piers of Ground Zero before all the constructions started. And so this is how the construction looks at the moment. And you can monitor the construction in real time by going to our website, elt.eso.org. And there is a live view webcam that you can see what's happening at the moment. And this picture is perhaps since a month ago. So you can see there how the telescope is being built in real time. And for comparison, here it's a picture taken from one side of this massive big hall with on the other side a multitude of people. This is the ESO Science Outreach Network representatives with which we've went a couple of years back to visit the telescope. Also the Irish representative was there with us. And here you see how tiny we all humans are as comparing to this big massive hall which will host this future telescope. And here small comparison with something which might be more familiar to you, the Spire of Dublin, how the ELT dome is going to be looking like as comparing to it. back towards myself and what do I do? Sometimes I do far less exciting things than traveling to observatories, and this is talking about the wonders of astronomy at various fora. And here you can see me giving a talk at the United Nations Summit on Space. So this was Unispace Plus 50, the 50th years anniversary celebration of the Treaty for Peaceful Use of Outer Spaces, where ESO had the honor to give a speech about the importance of astronomy as an enabler for space research, because astronomy has been always driving the fascination for exploration of humankind for centuries. And this is something that we sometimes forget, that when we go to space, that first it's astronomy, like what we can do from the ground. It's very accessible. Everyone who has a binoculars or telescopes or just their own eyes can look above to the stars and get fascinated by what we're seeing, and get gradually involved in various activities, space related, irrespective this is engineering, astronomy, or teaching, or many other opportunities, as Stephanie also mentioned earlier in her presentation. But what I ultimately enjoy more is visiting observatories. Here you can see me in a very, very happy moment, which was during an event in 2019 when a total solar eclipse passed over one of the observatories of ESO in Chile. So this is our first observatory, La Silla. And you can see the radiation of my face because what was about to happen was I was about to witness this total solar eclipse. So at the end, I did see a total solar eclipse. And this is a picture that I've snapped with my cell phone while I was trying to contemplate this amazing view that was in front of me. And yeah, so this has been my path so far in astronomy, and it's a fascinating endeavor, which has brought me to see many different places around the world, but I am absolutely convinced that the most exciting is yet to come. Thanks for your attention.
Maria, that's fantastic. Thank you so much. And it's such a personal story, and it's lovely to hear how it all began for you. Coincidentally, Claire McSweeney, who recently was working with us at Blackrock Castle Observatory, she was there at that at that eclipse with you. Yeah, she went to La Silla, and she said it was incredible. She told me about it. Oh my gosh, I really hope one day I get to see a total solar eclipse. They look terrific. Thank you very much, Maria. So shortly, there will be some of you that have the lucky privilege of getting a chance to talk more to Maria in a breakout session. And you'll be going in there for 20 minutes more, and you can ask her lots of questions and she can tell you more. And again, you know, in relation to the Creating Our Future initiative, you know, there are great questions that we can answer about looking into the night sky. So if you were an astronomy, what would be your biggest question, and how do you think it would impact your future? So these are the things we want you to start thinking about for our initiative, Creating Our Future. Maria, thank you very much. I'm going to call forward now our second speaker, which is Ashlyn Shannon. How are you, Ashlyn? I know that you're coming from ESTEC in Noordwijk in the Netherlands, which is ESA's Research and Technology Centre. And Ashlyn is a structures engineer. I was lucky. I met Ashlyn on my very first trip to the European Space Agency's Research and Technology Session Centre in 2014. And I think she was one of the very first people I met, Irish people I met, that was involved in space, which at the time was phenomenal for me because I was just embarking on my own space career journey. So Ashlyn, how are you?
Morning.
What's the weather like in Noordwijk?
Yeah, it's kind of damp.
Yeah.
It's that kind of day. I'm avoiding the showers at least, so that's good.
Yeah, great. Good stuff. So Ashlyn, you're going to, what's great is that you've got a great Irish story, and it's incredible what you've already achieved in your career. So you're going to tell us a little bit more for the next 20 minutes. And again, another team of people will get the chance to speak to you further in a breakout session. So for now, I think you can share your screen. So please share your lovely and amazing career story with us.
Okay, let's get that started then. Do you see it okay?
Yeah, I can see that fine. That's terrific. Thank you.
Just need to move one thing and then I can see it as well. Okay, So yeah, hi, thank you for the introduction, Niamh and Stephanie. My name is Ashlyn and I work at the European Space Agency, and I'm based at our site called ESTEC, which is the European Space Research and Technology Centre. I think I'll start off telling you a little bit about myself and how I ended up getting from Athlone to ESA. So I grew up in Athlone and I went to an all-girls secondary school. And to be honest, I had no idea at 15 that I was going to end up as a spacecraft structures engineer working for ESA. I had never even heard of ESA when I was 15 or even 18. And in the middle of Ireland, in a girls' school in the 90s, there wasn't so much talk about careers in space or even careers for girls doing engineering. It just wasn't really a thing. When I was choosing my subjects for my Leaving Cert, I had no idea what I was going to do. I knew I enjoyed maths, but really that was about as far as I understood. But it's one of the great things actually about the Irish education system is that you have a broad base. Some education systems really narrow your focus. And if you're like me, you don't really know what you want to do, then having a broad base and covering a lot of subjects give you so many more options when you're finishing and going on to the next level. And in my case, I think it was a bit more luck than judgment. I was looking through the list of university courses for all the universities in Ireland, and I saw something that looked really cool. And it was aeronautical engineering. And I had literally no idea what it meant, but I thought it sounds cool. So I'm going to investigate a little bit more. And as I read more about it, the whole engineering thing was opening up to me. And I hadn't thought about engineering as a career before that, but it just seemed really interesting and really along the line of how my brain worked and what I enjoyed doing. But I think, unfortunately or fortunately, the icing on the cake was actually when I went to talk to the guidance counselor about it. And I said, oh, I saw this cool course. It was aeronautical engineering. I'm really interested. And she kind of pulled a face and went, really? You're good at maths, I guess. Would you not rather go and work in the bank? And it kind of lit a fire in me that made me kind of think, well, you're not going to tell me I can't do that. There's no way somebody's telling me I can't do something. So that actually was more of an inspiration to me possibly than even thinking about doing the engineering course. So I stuck with it. I studied hard and I succeeded to get into aeronautical engineering in UL. And when I started, there were 7 women in the course out of 50 in the whole class. And again, I was actually quite lucky that I had found something that I really enjoyed. And I came across a lot of other students in the same class as me who thought they did, who thought, oh, aeronautical engineering, that sounds cool. But when they started doing it in first year, they thought, oh, it's not exactly what I thought it was, or it's too specialized. But the joy of it is when you do an engineering degree, the first year is really broad. It's really general. You're doing the same subjects as the electrical engineers, as the mechanical engineers, as the industrial engineers, as the production engineers, and quite a lot of overlap with the other science degrees as well. So even if you go into something and you get to the end of first year and you go, not really for me, you can change. So I quite a few friends who moved over to mechanical engineering or who moved over to material science, and all these possibilities are open to you that I didn't realize certainly when I was still at school. So that's one of the things that was really important actually, to understand that it's not such a big deal to make a choice, to feel that it might be the wrong choice, because you're making a step forward and it's taking you to the direction that you need to go in the end. So if we fast forward to my final year in aeronautical engineering, I picked a thesis with the structures engineering supervisor. I'd really enjoyed all the structural engineering aspects of the course so far. And the thesis was actually using a program for finite element modeling, which is a tool that we use to design and analyze structures. And it's actually still part of what I do today. So it's finite element modeling is abbreviated to FEM, and it's a tool to create a 3D model of a structure. And you assign properties to it. You decide what materials it's got, what thickness each part has, what are the material properties. And then if, for example, it was part of a spacecraft or a part of an aircraft, you apply a load case. You say, okay, I'm going to stick 10G down on top of that and see what happens. and maybe you haven't made it thick enough and it breaks, or maybe you've made it too thick and so it helps you design and analyze a structure without having to build anything, and to help you understand what forces have an effect on what structures. So the best thing about that whole experience was actually that tool is not used by a lot of undergraduates, or it wasn't at the time, because the license cost for the tool was very high. So when I went looking for graduate jobs, I was one of the few people who actually had experience with that tool. So I managed to get myself a job working for a company called GKN Westland Aerospace, who were based on the Isle of Wight off the south coast of England. Now, if you ask me what the weather was like there, always gorgeous. It was incredible. They took me for an interview there in May, and I left Ireland and it was like 12 degrees and raining, and I got there and the sun was shining. It was 22 degrees. It was glorious. It was beside the water. So I was hooked. But it turned out it was a really good job for me. They had a nice graduate program, which was 4 6-month sections in different parts of the structures team. But they actually call it the stress team, because in the aircraft industry, you're looking at the stresses and strains. So the people who look at structures are called the stress engineers. So I was a stress engineer for a while. And one of the rotations I did was actually in the dynamics group. And dynamics is not actually the normal part of aircraft analysis, because the load cases are static. But by doing that, it actually was the next stepping stone for me. So I had done a bit of dynamics, structural analysis, and that led me then, when I'd finished my graduate scheme, to move to a company called Astrium, which is now part of the Airbus group. And that was just north of London in a place called Stevenage. The weather was always terrible there. But the work was really interesting. It was my first introduction to Esa Spacecraft, and what they do at that company. They design, they analyze, they manufacture, they assemble, and they test spacecraft, not only for Esa, but also commercial spacecraft and military spacecraft. And I actually started off, let me jump forward. I'd forgotten about my presentation. So one of the first projects that I worked on when I started at Astrium was a spacecraft called METOP, which is a meteorological satellite. And there are 3 of those in orbit at the moment. And they're actually working on the 2nd generation of that here at ESA. And I actually came over to Nordvik about a month after I had started working at Astrium, because we were doing a test campaign for the structural model for METOP. So that was really a baptism of fire into the space industry. So it was really nice to kind of get a connection to ESA, and it certainly has influenced my career path after that. I then also worked on another ESA spacecraft called Aeolus, and that actually measures the wind, and it's a fascinating spacecraft with a LiDAR inside, looking down at the Earth and looking at the winds. And so after I worked at Astrium, I actually moved on to another company in the UK called SSTL. And there I worked on a spacecraft called RapidEye. And RapidEye was a constellation of 6 satellites that were doing a lot of crop monitoring kind of science, looking down at the Earth again. And the wonderful thing about that experience was actually that because the team that I was in was really small, you got a much broader scope of activity. So I was involved in the design work. I was involved doing analysis. I was doing the test plans. I was trying to decide what tests we needed to do in order to confirm that we would actually survive the launch. And then I was involved in writing the procedure for building the spacecraft and helping build the spacecraft. And then actually we put the spacecraft into a container, and I drove it in the back of a van to the test facility. So it was really, really cool to really actually have hands-on hardware, because when you work at a bigger company, you get a bit detached from the physical hardware, because the teams are so big. So there are specialists doing everything. So yeah, we ran the tests. We made sure that everything that we had done in the test was going to make sure that it would survive the launch that would happen later on. And if you try to imagine what kind of tests we would do, if you've ever seen a rocket launch, it's a lot of noise, it's a lot of shaking, and you can imagine all of these sensitive parts on a spacecraft, and they have to actually survive that. And that's what a structures engineer tries to do. We look at the vibrations and we shake our spacecraft on a vibration shaker table to see that it will actually survive being shaken. And then we often put them into an acoustic chamber, which basically fires noise at the spacecraft to see if it will survive the noise environment that is in the rocket as well, because sensitive parts like mirrors are very delicate and they can actually be broken just by the noise waves. So these are part of the things that we actually try and do with our testing. So after my time at SSTL, I moved on to ESA, and I moved to the Netherlands, and that arrow points you there to where Noordwijk is, and I live quite close by to there. And our site in the Netherlands, in ESTEC, this is the site, which is kind of huge. There are about 2,000 people on site when people are on site, not so many at the moment. And what you can see there is the sand dunes. So it basically backs onto the beach. And at the back of the facility, there are a lot of the test facilities. And then in the middle are all the offices. And then here at the front is our restaurant and giant car park and other activities going on over there. And there's actually even a little golf course. But that's just one of the strange things about the Netherlands, that you can't build on all of the land that you use for a business. So I have been working on many spacecraft during my time at ESA. The one that I've mainly been working on has been EarthCare, but one that I worked on in 2 different times was a spacecraft called SEOSAT, which was a cooperation with the Spanish government. And I worked on SEOSAT, I think, from 2007 to 2010, and then again from 2018 until last November when it launched. And it was it was the first time the Spanish government had funded a spacecraft that was developed by ESA, but built by companies in Spain only. And it was all about developing their capabilities in building spacecraft. And very sadly, the launch failed. So no fault of the spacecraft, but the launch, it was the return to flight for Vega, and something went wrong, and the launcher didn't make it to orbit, and so the spacecraft didn't make it, which is one of those things you work on for 10 years and then it's gone in a couple of hours. So it was a super tough day for everybody involved. For the majority of my time here at ESA, I've been working on an Earth observation spacecraft called EarthCare. I'm the structures responsible for EarthCare. And EarthCare is part of the Earth Explorers program, which is really about developing new missions for observing the Earth. What you see here is an impression of how the spacecraft will look in orbit over Earth. So what you see at the top is the cloud profiling radar, and that actually is an instrument that's coming from the Japanese space agency, JAXA. So we have cooperation with them. And underneath here, in the middle is our large instrument, and that's called Atlet, and that's an atmospheric LiDAR. And we also have 2 smaller instruments down at the bottom of the spacecraft called the MSI and BBR, and they're a multispectral imager and a broadband radiometer. And what you see kind of hanging out the back here are our solar panels, which are used to power the spacecraft. So we charge up our batteries before we launch, and then there's some charge, but mainly our power comes from the sun. And so we have large solar panels, and we generate all of our power for everything on the spacecraft that way. To give you some kind of scale, this spacecraft is about 2,200 kilos. The diameter is about 3 meters. And when it's stowed, it's 4 meters high. And what I mean by stowed is when we're in the launcher, this antenna at the top is closed over. The solar panels are folded back in onto the spacecraft so that you can fit inside the launcher. And then when you come out of the launcher, when you're separated from the launcher, you then deploy your antennas and your solar panels so that you can actually work in space. And when we're fully deployed, we're about 18 meters long. So it's a much bigger thing than our spacecraft will fly about 400 kilometers above Earth. and looking down and trying to understand about the cloud profiles and the aerosols. That's the main science function of the spacecraft. We've been working on Earth Care for a very long time. It's an extremely complicated spacecraft, so it's been, I think they kicked off the project about 2007. And we're hoping to launch mid-2023. So it goes for quite a while. So just to kind of give you some context of what I have to do for Earth Care, as a structures engineer, we initially look at the design. We do a lot of analysis work with simulations and calculations on the computer. But then the design evolves and we start getting confident that we've got the right design and we're convinced that it will work for the spacecraft and for the launch. And so we start building the hardware. And the way that we ensure that the spacecraft is qualified for launch is piece by piece. So we don't start off and take the whole spacecraft and test it. We start off with small parts and then we work from there. So this Atlet instrument that I was mentioning earlier, it's about 550 kilos. And that instrument is made up of two main structures. So there's the external one, which is the housing structure, and the internal one, which is the stable structure. And the stable structure is where all the important instrument parts are. So we have a telescope on there and laser heads, and the structure has to protect those parts because they're extremely sensitive. So the structure has to really make sure that it somehow separates it. You separate the items that are on that structure from any of the vibrations that are going on in the rest of the spacecraft. So it's kind of isolated and protected away. Several years ago, we started off and we tested the stable structure, and then we tested the housing structure, and then we assembled the whole instrument and we tested that. And then the team responsible for the instrument delivered to the team responsible for the spacecraft, and they assemble it into the full spacecraft. And then we're going to test the full spacecraft with all of the instruments early next year. And to give you an idea, so I said it's about 550 kilos, and you can see those zigzag struts on the spacecraft there. I don't know if my cursor is working, but the zigzag struts there, the instrument sits inside there. So what we had to do was basically turn the spacecraft on its side and drop the Atlet instrument into that space. And at certain points, the clearance is 3 millimeters. And we were able to lower a 550 kilo instrument into that space. And then our engineers then worked and bolted it down to the interface panel. So we're really talking about high precision. And the structures part is the kind of hard and dirty part, nothing dirty about it, but it's not the really fine instrument science, but really we have to work with very tight margins the whole way through. So at this stage now, we're kind of heading towards our spacecraft environmental test campaign, which will actually take place here in ESTEC at our test facilities, which is nice that I don't have to spend 3 months down somewhere else around Europe. So it's very good. So what we will be doing is we have to do mass properties measurements, because we want to know, not only do we want to know the weight of the spacecraft, but we want to know where the center of gravity is, because that affects how the loads act on the spacecraft, and how the launcher is going to be able to get the spacecraft into space, because you need to keep it really on the axis of the launcher, otherwise the launcher might start to wobble, so they don't let you do that. But also after the vibration testing, there's going to be thermal testing, because spacecraft go through, I think you saw it on that little video from Esa, the temperature ranges are huge, and temperatures can break a spacecraft as well. So there's a lot of things to consider going on there. But yeah, so that's, I think, pretty much all I had for my little presentation. But I just wanted to kind of wrap it up there and say that I've been here at ESA for about 15 years. And it's an amazing career. It's an amazing way to spend your life, to really be working around so many amazing projects going on. I think we're developing maybe 20 or 30 spacecraft at the moment. And when I talk to people, sometimes it seems so far from home. But for me, I'd like to say that I didn't make that one step from Athlone to ESA. I made a small step towards aeronautical engineering, and then I made a small step towards aircraft engineering, and then I made a small step towards spacecraft engineering. So it's one of those things. It's not beyond the reach of anybody. I'm just a little girl from Athlone, so like if I can do it, I think it's fairly accessible for most people, to be honest. And that's pretty much it for me, I guess.
Thanks, Ashlyn. Well, your passion is really infectious. Like you can tell, you just light up when you talk about this stuff. And yeah, I think the Technology Centre, STech East, I think that's a really special place as well. So it's lovely that you get to work in such an interesting place, and they're lucky to have you because you really, I can tell you really care about this. So this is where the engineer has found their absolute passion project. So thank you so much for sharing just a little nugget of your life. I hope that it helps people to understand that you start as an engineer and you can go in any direction really. And what are the big things you want to solve? What are the big questions that you think we need to be thinking about for our future? And that's essentially it. So it's back to the creating our futures division again. So Ashlyn, you're going to go into a breakout room, and some of you are going to have the delight to talk more and find out more about some of the aspects of Ashlyn's career in relation to structures and how that relates to space, and maybe there's a future for you in that as well. So thank you so much again, Ashlyn, and I look forward to seeing you sometime soon on site. But we'll have you back later for the main Q&A session. So thanks. So now our third speaker this morning, and she's very kindly gotten up very early. She's speaking to us this morning from Canada, and it is Prashati Patel. You heard Stephanie give you a little bit of background behind her there. She's an astrophysicist and a science communicator, and she's normally based in London, Ontario. She is based in London, Ontario, Canada, as education outreach for Western University at their Institute of Earth and Space Exploration, but she's been seconded to the Canadian Space Agency. So we're very lucky to have her. Good morning, Prashati. How are you? And where are you? And what's the weather like where you are? Is there even sunlight outside yet?
It's still dark actually out here. So yeah, I'm in London, Ontario. It's a tiny town, 2 hours from Toronto. Everyone knows Toronto in Canada. So yeah, I'm really excited to be here, and I'm excited to share my journey. I really loved watching.
Thank you. Yeah. It's 6 a.m. where you are, isn't it? It's 6 a.m. It's not even.
It is 6
p.m.
Oh my God.
Yes. Thank you so much. You're so good to join us. Thank you so much, Prashati. But let's use this 20 minutes. I'll stop talking. So if you have slides there, maybe you can share your screen, and we'll hear a little bit more about it. And for the rest of you, some of you are going to be going with Ashlyn now into a breakout room, probably in the next few minutes. Once Maria's end, Ashlyn, I think you're going to be going in there. So just hang tight there, Ashlyn. So Prashati, tell us about what you've been up to over the last few years and your space journey.
Thank you. Can you just confirm you can see my slides?
Slideshow? I can see it fine. Yeah, can see that.
Awesome, thank you. I'll share my journey into astronomy and science communication and education. I generally call myself a stellar detective, or at least I used to when I was studying stars, because studying stars was my passion. And when I was very young, I used to watch a lot of crime shows, and I just always wanted to be a detective. So I used to dress like a detective, act like a detective everywhere. And it turned out that when I went into astronomy, studying mysteries of the universe is very much like a detective, because you're putting puzzles together, you're trying to solve mysteries. They're not crime mysteries, but you still have to use every bit of information you get to try to understand what's around and the questions you're trying to solve. So I'll start with a bit of where I got inspired to even study astronomy. I was born and brought up in a tiny city called Ahmedabad in Gujarat, India. while it was a city, there was, a lot of light pollution, and, you'd see some stars and maybe the moon, but really that's how far it would go. And I was never like, inspired to look up or anything like that. But it wasn't until a chance visit to a planetarium, actually, in a city called Mumbai. It's the largest city in India. And we were there as a tourist. And one of the things to do was to go to a planetarium. And that was my first ever kind of encounter with the night sky. And it's bizarre to say that I'd never looked up at the night sky in that way until that planetarium show. And the moment I learned about that show, people generally are like, oh my God, that is amazing. That was great. And I was like, yeah, that's good. I have more questions. I had more questions, and I tried to ask my parents. They did not know many answers because they didn't have a background in astronomy. My mom is a macrobiologist. My dad is a business person. Like they did not know anything. And they were like, oh, you know what? Like, we don't know the answers. Just go buy books, and, hopefully the answers are in there. And so we went to the bookstore in the planetarium. We got some books, and I read the books over the next couple of weeks, and I just had more questions. And so, I kept asking for more and more books. And eventually I think I had like a whole cupboard of books in that were all about astronomy. And I was fascinated by it, but I didn't ever think that would be like something that I wanted to do for my career. It wasn't really until like a bit of a year later, this was in my teenage years, my aunt, who was coming from Canada, she said, is there anything I can bring for you? And I was like, well, anything related to astronomy would be awesome. And I was expecting more books from her, but it ended up that she got me a small telescope. It wasn't this exact telescope, but it was something along this size. Wasn't really big, but just enough to look at the planets, look at the surface of the moon. And I remember the first time I went up to my terrace, and it took me a while to set it up. And the moment I got to see the surface of the moon, I just knew that like it blew my mind. It just like I knew that this was something that I'd never like experienced before. And then when I was able to like point it to Saturn and Jupiter, and I distinctly remember them being in the night sky at that time, I was just like, wow, if this could be a job, I could do this. Just watching these things all the time, like that could be a cool job for me. Obviously, I did not realize at that time that no one sits around and looks at, the night sky all day, every day. I mean, there are observational astronomers who do that, but that wasn't going to be my case, the case for me. But that really gave me that first insight into, ooh, this is something I could do for a living. And, over time, I come from like just the era of the internet had started in India, and I didn't really have like, there wasn't any Google or anything. But really the books gave me that inspiration to be like, okay, let's, find out more what intrigues me more. And I knew that I wanted to do something related to planets and stars. And I think probably the reason was that we could see the sun, we could see other stars, I could see planets using my telescope. I thought that was something that was, in my reach in terms of I can see them, I can try to understand them, I can see why I want to know more about them. Even though I knew about galaxies and all of these, other things I could study in the universe, I was always fascinated by planets and stars. And I really did not know where to go in terms of education because there weren't any bachelors of astronomy in India. I knew that you could do a PhD in astronomy at that time, and this was 15, 20 years ago. And I was like, not sure where I would want to, which path I would want to take. A lot of people try to tell me to go into engineering because they're like, you can do engineering and then you can go and do whatever you want. And I'm like, I really don't want to build things. Like, I really want to understand the nitty gritty details of how stars and planets form and why they are the way they are. And so I remember I had a chance meeting with a scientist at a birthday party, out of every other place you can think of, at a birthday party, who was working at this physical research laboratory, which is where a lot of the physicists and astronomers in my city actually work. And he suggested, why don't you try to go abroad? But as you wait to do that, why don't you look into physics and math? Because you're going to require that. And so I ended up, starting a bachelor's of physics after my grade 12. And this is me, like super young, at the college that I was at back home in India doing my bachelor's of physics. And even though I was studying physics, I knew that was kind of a stepping board to astronomy. I wasn't really satisfied. I was like, I need something else. Like I need to study astronomy. Like I cannot just be doing physics and math, until I find a way to get into astronomy. So I was lucky enough that I applied to Canada, and I got into the University of Toronto, which had an astronomy program. And when I landed here, I was so mesmerized by all the courses I was able to take. And then I realized that, I'm like not the smartest person in the room. I need a backup degree as well, just in case if I don't get into master's or PhD, like I need to have something as a backup. So I ended up actually doing a bachelor's in physics and astronomy, so having 2 degrees, because I was like, physics will be my backup to get into industry in case astronomy doesn't work out for me. And I think in a way it was great, because then it allowed me to take courses that I'd never thought of before. Like, for example, I took a holography course. I'd never thought of making holograms as assignments. I thought that was super cool. I was able to take geology, geophysics courses, all of these things that just expanded my horizons on what could be done, even if you're just talking about physics or astronomy. And even with all that exploration, I was really, inkling to do something in astronomy. And so I had an opportunity to actually do a 4th year course. It was a research course where you actually get to do research for 8 months. You basically pay to do research, which is super cool. As an international student, that is an opportunity to actually do research here in Canada, at least at that time it used to be. And I started with a simple project of just understanding how planets move around as they're forming in this disk around these stars. And I found that it was something that I really liked. So something about that, trying to solve a question that no one else solved before, and trying to come up with new ideas and ways of making this thing work. How is it working? We know it works. We just need to figure out how. And I really enjoyed that. And I knew that that's like what I wanted to do. So I was able to apply to many schools here in Canada. And I ended up at Western University, which is now where I'm based. And it's a beautiful campus, reminds me of Europe a lot, many times. But the one really neat thing about choosing Western was that they not only had the master's and a PhD in astronomy, they allowed for a specialization in planetary science and exploration, which meant that I wasn't only going to study what my research topic was going to be. I was going to take courses outside my research area that are more related to planetary science and space exploration. So trying to understand, everything from how meteorites came into being to, just studying how Mars missions work. All of those, different aspects of space in general, everything from business to engineering, I was studying in that program. And so it was really helpful for me to kind of step outside my normal astronomy zone to understand space. And I think one thing I really liked, and I kind of stayed for my PhD, and I'll talk a little bit about my research in a second, but I really liked that I had opportunities to do other things with my PhD. And trust me, when you're doing research, you do want to have things alongside that you do that aren't just about research. So that, one of the things that I really loved was actually going out and presenting a lot of the work we do. And here, I just added a picture after seeing Maria talk about ALMA. I actually was able to visit to the European Southern Observatory in Chile to present my research, which I thought was super cool. And I did not really know at that time that I really liked talking about it, but it was an opportunity that I had just to learn from other researchers and actually be able to present my research as well. And I really enjoyed that experience when I look back at it. Other few things that I got to do while I was at the university doing my graduate degree was actually doing outreach. And it was part of my teaching assistantship, which means I got paid to do it, which again is, is something that you want to be able to cultivate in terms of the skills that you get, during your graduate school. And I was able to work at the observatory that we had on campus. Here it's me looking through the telescope that we have. It's a very small telescope. It's not used for research anymore, but it's really used for public outreach. And it gave me an opportunity to, learn English. And English is my third language. So, to practice my English and to present in front of people, which I was very terrified of it to start, but now kind of do it for a living. So, it really gave me that opportunity to do that. But in terms of research, when I started my bachelor's, I was really, really interested in just studying stars and planets. And so for my bachelor's, I studied planets and how they form and move around in the disk. For my PhD, I actually had an opportunity, and even for my master's, to choose what I wanted to do. So I really chose young stars. And in this, a slide here, I have an image of Orion Nebula, one of my favorite star forming regions, or a stellar nursery, as we like to call it. And we have, snapshots of these young stars that are forming that were taken by Hubble in 90s. And, it may look like they look all very different, but what's really interesting that these are all young stars, and these are all just in their baby phase, as we like to call it. And the diversity of stars that you can get just by looking at this small subsection of the images that we're getting right here, you can see some have like giant jets, some have these winds that are blowing material around them, some don't have jets or any of the material that's being blown around. So I was really interested in studying how these things are actually forming and what is happening to these stars. And the most interesting part is that most of these stars are forming behind this really thick wall of dust and gas. So we cannot really see how these stars are forming, but we can really get the light from them and infer a lot of things from the light. And so for part of my my graduate studies, what I was able to do was actually able to use amazing giant telescopes. And, I, unlike Maria, I didn't get to go to them, but I could apply and get time on them and get data from them. And, here is the Canada, France, Hawaii telescope in Hawaii, one of my favorite telescopes, where I was able to get time and observe the 4 stars that I studied for my PhD, for the 4 hours that I really needed the data for. And what's really interesting is that, these stars are hiding behind this wall of dust and gas, and all we're really getting is light. And we're splitting this light into these lovely spectrum. And depending on what you want to study, you can take the part of the spectrum and study that part. I was really interested in the visible light, the light that we can sense, and a little bit of an infrared light, and how the material around these stars is impacting the star itself that is forming in the middle. And while you would have all of these data, a lot of the observational astronomer, they take data, but then I was loving the combination of incorporating my skills as from computer side and merging that with the data that I was receiving. So I was very lucky to be working in a group that actually had computational data. But what was I really looking for in terms of the data that I was getting from the stars? So this is just a snapshot of that lovely visible spectrum. But this time I'm looking at all these different stars. So on the top, we have the most massive, to the bottom, we have the least massive. And if I look at that lovely spectrum, all of these dark lines that you're seeing, these are all like fingerprints of material that you can find around the stars. These are elements. And just like what I said before, like as a detective, you look for these, unique things that you can attach, it to the person who's actually committed the crime. Here, there is no crime, but really what we're looking for are these fingerprints that tells us which elements and materials are present around these stars, and then take that and be able to reproduce that in a computer is just, it's mind-blowing. We live in an era where we can actually do this. And, my particular area was really looking at these massive stars up here in the first 3 panels and looking at these stars and trying to figure out what material is around them and what can we understand of how this material actually transfers onto the star. And the way we would do it is, like I said before, we would have a computer model that would do it. And we would create a star and a disk around them and try to figure out if the observations that I have from the data are exactly what I have it from the computer model as well. And we compare the two to figure out, what state the disk is in and, how big the star is in the middle. We're guessing a lot of things and trying to figure out whether or not it matches. But really, that's how you get started. That's how you start understanding what's happening around this material that you cannot actually go and visit, and that's, I think, in a way, is a beauty, is you sit far and try to figure out what is happening just without actually being in the chaos of things. And I really enjoyed this experience because it really allowed me to do this tweaking. I felt like this pilot, sitting in the cockpit, trying to like change all the knobs and trying to figure out which one actually works perfectly with the star that I'm seeing. And I really loved that experience. But I realized that as I was doing more outreach during my graduate school, that I really love talking about it. I didn't get as many opportunities during my PhD, but I really, really love talking about space and how amazing that was, and all the experience that I'd acquired over my PhD. I really thought I would be able to translate it to some place. But just to give you like a snapshot before I move on to my life as a science communicator, I did a lot of things that I think, a lot of people don't think about as part of your PhD or as part of your research. It would be, writing, observing proposals as it's a competitive thing that you do as part of your PhD, or just as a training as a researcher. You're cleaning the data, you're analyzing the data, you're writing a lot, whether you like it or not. You're coding your computer models, you're reading other people's work. I think I spend most of my time reading what other people did. And then obviously presenting your research to other people, because you want the world to know, what you just found or what you're trying to work on to get help from other people. And so, it's like a circle. You keep going and like you really keep doing it for as long as you love doing it. And then I loved my time as an astronomer, but I really, really loved my time talking about astronomy and talking about my research and other people's research. And so I decided to transition into this life of a science communicator past my PhD. And I did not realize at the start how many things you could do as a science communicator. And it's such a broad word, science communicator, but you really get to, you can define what you really want to do, very, very specialization or very, very broad field it is. And some of the things that I've loved over the years to do is really training people, training graduate students, training educators to talk about space, whether it's with students or public, talking to media. I get to talk a lot about, anything that's happening in the night sky, or, like that's a meteorite that fell and we're talking about that meteorites the next day in the media, podcasting. I think I was podcasting way before podcasting was a thing. 10 years ago, like I was doing a radio show and ended up being a podcast later. So, sharing again, knowledge of the field that I just acquired during my PhD. Program development, developing programs for students, public, educators, is kind of my thing now. Also doing public events, going to schools and universities, talking about not only my career, but also about, different fields of careers you can have in this particular space field. So it's a very interesting. And then last but not the least, and probably the newer part of my job, is to really be doing social media and reaching out to people online and not just in my area of where I live. And then, more recently, I think I've kind of started picking up things as I get more into this field, is science consulting. Just as an example here, I am standing right next to Dr. Dave Williams. He's a Canadian, retired Canadian astronaut, and he was writing a book on, living on other planets for kids. And they reached out to me and said if I wanted to do science consulting, and this is something I'd never thought about doing. And, kind of opportunities knock at your door while you're trying to think of these things that, is part of the life of a science communicator, but something I never imagined I would be doing. And then something I've been doing more recently is science writing. It's something that I've started wanting to do. A new book that is just coming out next month is working with DK
Congratulations.
for young kids. Thank you. And yeah, it's something, again, that I never thought about, is writing. And then I just wanted to kind of quickly share, I didn't leave research behind. I'm still doing research. It's just in a different field. It's in the field of STEM education, just making sure that I understand what impact of my programs that I'm developing are having, whether people are actually taking in and getting excited about space with the programs I make. And then I would just like to leave you with the last slide. Apart from just doing what I just showed you, there are lots of different aspects of science communication, and you can specialize in one or just do it all. And I'm so fortunate enough that I get to do everything. So I will just leave it there, and thank you for having me.
Thanks, Prashati. It's so interesting, isn't it? You know, you started with the gift of a telescope, and look what's created. And you know, it's incredible, like, that English is your third language. Like, you know, you really are so inspiring that you've just plowed forward, and it's a constant that's been in Maria's story and Ashling's story and yours, is that, you know, you just don't let anything get in your way, and you start in one place and then all these different things emerge from it. So thank you so much for sharing that. So now you go into a breakout session. So some of you also have the chance to talk to Prashati in a little bit more detail for the next 20 minutes. And then Prashati will come back and we'll have a general question and answer session. Don't forget, there's a competition for best question, and a school gets something, but also you get like an Esa hoodie and some nice notebooks and those pop sockets at the back of your phones and everything. So Prashati, we leave you now. You're going to disappear into a breakout session, so that's great. And we're going to now go back and talk again to Maria and Aisling, and also the amazing Danielle from Blackrock Castle Observatory, because I don't know if you've noticed it or not, astronomy has come up a lot this morning. And I think even Aisling, you were saying before we started that there's a telescope on board the spacecraft that you're designing as well. So we're going to talk a little bit more about telescopes and why astronomy is important. And again, thinking about your future, what questions do you think we should be looking at when we look at the night sky? So Danielle, I'm going to start with you just to give us an idea. There's one telescope that is there's no way you're not going to hear about it, folks, by the time we get to December. There's a massive telescope that's being launched to space to replace the beautiful Hubble that we all love, and that's the James Webb telescope. So Danielle, tell us a little bit more about that, and then also some of the telescopes that are happening at Blackrock Castle.
Oh yeah, I'm surrounded by telescopes, and you can see them behind me here, but I've got another one just out of view here, one in front of me, 4 or 5 in front of me over there. It's my dream to be surrounded by telescopes all the time. I absolutely love it. And I hope for everybody that's watching that you've noticed that everyone that's been talking about their career in space, you can just feel the passion that they have for it. It's just a really cool field to be in. And you might notice I'm a little excited about what I do. So I work at Blackrock Castle Observatory down in Cork, and some of the students that are watching may have visited us. You can come see us here and come see some of the telescopes. And like Niamh mentioned, there is huge telescope news this year. We have the James Webb telescope that's going to be launching very soon. Right now, it looks like the launch date is going to be in December. So we're very, very close. That's right around the corner. Can you believe it? We're creeping up to the end of the year here.
Yeah.
Telescope is going to be a big deal because we have these beautiful Hubble images. And most of everybody watching here probably grew up looking at these. I remember when Hubble was launched. I remember being in school and seeing these images coming back. And I remember the impact that they had, these beautiful colors, these beautiful images. And it really just kind of revolutionized how we see space.
Yeah.
And I'm hoping, and I think everybody is, that James Webb is going to be no different. We're going to have a complete, it's the next step up for what Hubble is. And this is going to be, it's slightly different. Telescope is going to be looking even further back into time than what the Hubble is. James Webb is going to be looking at around 250 million years just after the Big Bang. So we're going to be looking at that era in space where we have galaxy formations and where stars are starting to form and things. And this will be our first time really looking at that. So that's really, really exciting news. And I encourage everybody to be going and looking at what NASA and ESA are putting out, because they'll be putting everything out on social media as it goes. So it's a big thing to be looking at. And I'll show you what it looks like, actually. It's a really cool looking telescope. It might not be what you think of. I'm just share my screen.
It looks like a ship. I think it looks like a ship.
A ship. Yeah, that's a comparison, actually. It's got this really cool, I actually think it looks very artistic. Like I would love to have a mirror in my house like this, actually. Can you see the
Mm-hmm.
image there?
Yeah, yeah. And what about ESA's involvement in it? How are ESA involved in James Webb? I know that it's launching from Kourou, isn't it? So that's the ESA Launch Center, and it's being launched on the Ariane 5, or is it the Ariane 6 rocket? So ESA's very involved, isn't it?
Yeah. So, you see the NASA logo in there, and you see the Goddard Space Flight Center next to it in the reflection there. But yes, ESA is involved. So it's a joint collaboration, which is really interesting. And that's a big deal because Ireland's part of ESA. So that means the Europeans have, we're doing stuff in space. I'm just going to stop this real quick. Actually, while I have it, I'll show you some of the stuff that we're working on down here in Blackrock. Actually, hold on. Actually, I'll just stop sharing the screen and I'll reshare it. So I'm at Blackrock Castle Observatory, and we also have a telescope on site in the observatory at the top of our tower. So I'm just going to share a few pictures, because if you haven't visited, I'll show you what the site looks like, because we're called Blackrock Castle Observatory, but we actually are a castle with an observatory on top. So, oh no, that's still seeing James Webb there.
We're seeing loads of your pictures. Maria, have you been touched by James Webb? I know that you've got the you've got the ELT growing, that's probably the massive one that you're looking at from the ESO, but does James Webb touch you in any way? I mean, I know it's an amazing telescope.
Oh, absolutely. I'm so much looking forward to the launch in 2 months from now. Fingers crossed that everything goes well. And as an astronomer, I'm looking forward to use it to look deeper in the hearts of galaxy nuclei. That's what I'm very much interested. But one of my PhD students who just finished earlier this year, and now she has moved on to for her next part of her astronomy career to the European Space Agency in the Netherlands, in the ESTEC, where Ashlyn is, so to do her fellowship there. And she's particularly well equipped and looking forward to use James Webb also for her research, and through that I hope also to continue this collaboration and to use it. And these telescopes, the James Webb and the ESO's extremely large telescope, they will be very complementary. So that's what we at ESO now, we will really have to do our best to stay on schedule and to build the ELT as planned with first light 2027 to make maximum time that the two telescopes, James Webb and the ELT, will be operational together to observe, because there is not their place for competition, who is bigger and who is better, but it's about collaboration. One telescope will be good in one side and the other telescope in other capability. So it's really important that these telescopes get to work together. But James Webb has been so many times delayed, so we're really, really hoping that it goes and there is green light for launch. And it starts sending these amazing pictures.
And Ireland's membership of ESA, what does that mean for Ireland? Like, for people that are tuning in today, people like Danielle, they love astronomy. How does Ireland's membership of ESA give us more access to all the different telescopes around the world?
So as a full member of the European Southern Observatory, Ireland actually does own these telescopes. So you can be really proud of being an owner of these amazing telescopes. So as a member state country, Ireland has the absolute right to bid for any industrial contract to build any of these infrastructures. Also, a lot of science institutes are involved in construction of future instruments. For our junior audience, it might be very interesting that Ireland has a special agreement with ESO through the Irish Research Council to have funded scholarships for PhD students, which are sign up for PhD program at an Irish university to come to ESO, either in the headquarters in Germany, where I am, or in Chile, where the telescopes are, and spend 1 or 2 years doing their research. And this, we have already had Irish students participating in this program. It was launched about 2 years ago, so it's a very young program, but it has been very, very promising, with a lot of interest from Irish students as well. But also
Very
there is, so this is like really something that it's for me very important, is the national pride that comes with participation in such a mega project. It's like you really own this big telescope of the future.
Yeah, and do you have any classroom resources? So that's for research. Is there any sort of school resources that we can that the people watching today can avail of from ESO?
Definitely. ESO has a special educational center called the ESO Supernova. So this is an open source planetarium and visitor center. You can come and visit us. It's located next to the headquarters, next door really, in Garching, close to Munich. So it's basically Munich airport and 10 minutes away from it. And so in this planetarium and visitor center, we do have a lot of educational resources and educational workshops for students. Something very important that we do is we organize teacher training programs. So teachers from Ireland can visit and take part in a teacher training program, and then go back and bring the resources and the knowledge that I have gained to apply in the classroom. Also, we do run a lot of virtual virtual visits to the observatories. These are accessible via our Facebook and YouTube channels. So if you go to ESO Astronomy on Facebook or YouTube, and we run these virtual visits live every weekend. At the moment, we can't host visitors on the observatory, so we've decided to scale up and actually start hosting the full world, not only those who are fortunate enough to travel to Chile and come on site. And our most recent endeavor is starting educational visits for schools. At the moment, they are being run in Spanish for the local schools in Chile as a startup, but we will continue with that in also offering this in English, and then schools will be able to book a virtual tour to the observatories, talking with astronomers working there in real time and asking all their questions.
Brilliant.
And the Supernova and Visitor Center, the ESO Supernova, all the content is absolutely for free available. The digital content, being these exhibitions or electronic panels, and any digital content that is on display in the Supernova, one can take it and use it.
That's brilliant, Maria. Thank you very much for that. Danielle, coming back to you now from Ireland's point of view, what are you doing, and what interesting stuff are you guys getting up to in all your amazing telescopes? And show us your slides. I want to give you some minutes there to catch up.
Yeah, now I realize why I wasn't sharing properly. But yeah, the thing with like James Webb is looking at stuff in infrared, but we look at things in optical. So that's a tricky thing in Ireland, because we're dealing with light things that you can see with your own eyes. That's what our telescopes can see, which is farther into space. But that's tricky when you have a lot of cloud cover here. But for me, what I think is that I have a lot of friends who are astronomers in the UK and in Scotland, and we talk about this a lot because the big telescopes like ESO are built out in the desert, and they're high above in dry air, fantastic weather. But because we have so few good days here, it makes it just really, really special when you get out and get to use the telescopes. So I'll show you what we're using over here in Blackrock, and I'll just go ahead and share the screen. We've got inside of our observatory, we've got a nice telescope that if you come and visit us, you'll actually be able to see. So here we go. Can you see a single picture there? You should be able to see.
Yeah, I could see one picture now. Yeah, that's great. So there's
the
castle.
This is the castle. If you come see us, you walk straight into the courtyard, and this is what you see. We have the tower there is the big tower in the center. You see there's like a white dome on top. I don't know if cursor there. And that is the observatory. So inside, I'm going to go through the pictures real quick here. So this is, up on the roof, we actually set out some of the smaller telescopes. These are the telescopes I have in front of me at the moment. So this was doing a bit of observing of the moon during the daytime. So sometimes we can do a little bit of observing, but most of the time our stuff is done at night. And this would be an example of one of our larger telescopes. We have a 10-inch, this is a 10-inch Meade LX200. And this night I was actually taking pictures of Mars. Mars was in opposition. So it was a fantastic time to see Mars, because that's when it's fully lit up, kind of like a full moon, but for a planet. And we're just out there firing off images. It was a beautiful, beautiful night for Mars. But this is Big Bertha. She's the one that's sitting in the dome on top of the tower. And if anybody owns a telescope, it is an absolute necessity that you name it. Every telescope has to have a good name. And Bertha lives up to her name. She's a 16-inch optical telescope. So when we talk about sizes, we say 16 inches, it's actually the size of the mirror in the back of the telescope. And so the mirror on Bertha, which is in the back here, is 16 inches. So mainly we're using Big Bertha, just to give you an idea of size. That's me next to Bertha there. We are mainly looking at black holes and exoplanets with Bertha. We look at all sorts of things. We look at the moon, we look at Mars, we look at other planets. But for the most part, with the research side of it, it is black holes and exoplanets. And we connect to a laptop. So we're not actually looking through, the telescope specifically. We're using software on the laptop and guiding the telescope around the night sky that way. So that's, you can see me there with the laptop next to Bertha, picking out where I want to go, having it focused on a specific spot in the sky, and then I can tell it to start taking pictures. And so we have our camera at the back of the telescope as well, which is also connected to the laptop. So everything's connected and motorized. So we're not physically moving Bertha around. Everything is, we have commands that go through the laptop there. And I've got a few images. This was such a good night. It was a beautiful moon as it was setting, beautiful crescent moon. So as it was setting, it kept getting, went from this golden yellow to an orange and then just red, just go red straight through until it's set. But just a beautiful, beautiful moon over Cork City. And if anyone knows about Cork, red is kind of a special color for the Rebel County. So we named this one the Rebel Red Moon. This is one of the deep sky objects that we do. So we do, like I said, all different objects in the night sky, but this is the Ring Nebula. This was the first deep sky object.
Beautiful.
Picture of. And we take pictures in black and white, and then we stack them after in the software. So we'll do we use different filters. We have a red, a blue, a green, and a luminance. And so we take images in each one of those, and then we stack them on top of each other to get these beautiful colors. But the Ring Nebula is just gorgeous because it looks like a rainbow in the sky.
It's stunning. It does. It's beautiful, beautiful, beautiful.
So this one's a tricky one.
Lovely.
It's like nothing but stars, right? Just a few dots. But actually, there is a supermassive black hole in this image. And this was taken.
Wow.
And I will actually show you in the next one. This one is the supermassive black hole. So that is 0716 plus 714. That's the name of it. And it's 4.26 billion light years away. 100 million times the mass of our sun. This is a huge, huge object that is powering a galaxy very, very far out in space. So that telescope that I just showed you, Bertha, she's able to take images like this. And what's really cool about it, it looks like a star. We call these quasars because they're quasi-stellar. They're like a star. But what you're looking at is a jet. So this is a jet stream that's pointed straight at Earth. So you're looking down the jet stream of a supermassive black hole. So this is cool. This is what I get to do for my job. I get to take pictures of
great
and objects like this out in space.
Fantastic. I'll just bring Ashlyn in if that's okay, Danielle.
Yeah.
So Ashlyn, you were saying on your Earth scores. That was Earth Care. That there's a telescope on board that, isn't there?
Is, yeah. I'm not your telescope expert, but we've got an atmospheric LiDAR. And so there's a 620 millimeter aperture telescope on that. So what Atlet's purpose is to provide vertical profiles of optically thin cloud and aerosol layers with different resolutions for different altitudes. So yeah, it's actually never been flown before. So this is what we're trying to achieve, is because what they discovered when they started developing the LiDAR for space is that they struggle to work in a vacuum, which is kind of an issue. So this is why it's taken us so long to actually develop this LiDAR to really counteract the fact that we're in space. So we have a pressurized laser head so that the laser head is actually pressurized, so it's not in a vacuum. And we also separated the emission and receive, because that actually helps a lot with the signal coming back from Earth, so that you don't end up basically because a similar instrument is on Aeolus, which is measuring the wind, but they have a lot of issue because they send and receive on the same path. So it's very difficult to separate things then. So, but from my perspective as a structures engineer, the main important thing with the telescope is to try and understand how I can make sure that it will work up there and it's not going to get affected by, we have something called micro vibrations, which clues in the name, even the smallest little vibration, and you're talking about fractions of 1G, like 0.05 of a G, can actually offset your whole instrument and make it impossible to actually get any readings. So a large part of what we try and do is to keep those micro vibrations away from the sensitive parts of the telescope so that you can actually get good science from the instruments when you're using it. Because we have systems in the spacecraft called reaction wheels, which are used for fine pointing, but they induce a jitter. So you have to really, it's these little tiny things inside that can actually destroy a whole mission and mean that you don't get any clear images coming back down to Earth. So yeah, that's my side of it.
Very intricate. Okay, thanks, Ashlyn. So then lastly, we'll round it up because we see Prashati's come back and the other groups come back from the breakout sessions. Maria and Danielle, what advice would you give people who are interested in astronomy, like they want to pursue it or something? How did you get started, Maria? How do you start in something like astronomy?
With curiosity and not stop studying. So for me, what was foundational about this very early interest and my physics teacher really answering all questions that I had in high school. And then I went on to study physics and mathematics, because that's what is what requires the first years of formation in any astronomer studies. And I was fortunate enough that I've been born in Sofia, Bulgaria, which has an old university which also teaches astronomy. So I did not have to move outside of home to study astronomy. But once I was growing up, kind of, it was not enough what I was experiencing at home. So I wanted to experience more the big world and see. And what I started doing was apply for summer schools in astronomy. And this is something that I can definitely recommend to anyone, which schools are accessible not only for university students, but also there are such initiatives for high school students to do research in astronomy or in anything else that interests you. So this was really the big kickoff for me. Such a summer school that I've attended when I was second year at university, and I got to meet a lot of astronomers from around the world, a lot of students like me interested, and this is how I started building my network with astronomers that I know, and through that I got to learn about more further opportunities like that and so on.
Brilliant. Okay, thanks, Maria. And Prashati, I know you started out as a keen astronomer as well. Any advice for anybody listening today that you would give about how you get started? How do you find your tribe? If you just come off mute, Prashati.
Apologies for that.
Not at all. Not at all.
Yeah, I think Maria added what I really wanted to say. Summer schools are a good place, as you know, to start for high school students and undergraduate students. I would also say summer research is something also that you could do. Is, you know, a lot of the university professors are also taking in high school students and undergraduate students for the summer research, and that's a good starting point to see if this is something that would be of interest to you. I did not have that opportunity until year 4 because I was an international student, and they generally don't take international students. But you know, just having that opportunity to do research, because it's very different from taking courses and you know, doing an internship. You know, you're really building knowledge and learning how to do research and how to read papers and how to do all of these neat things that you will be doing if this is where you would want to go. So it's a great way to get your first step into it, and also build a portfolio. So by the time you want to apply for a master's or a PhD, you will have a whole research, you know, portfolio that you can present. So I would say a summer school and summer research are a great way to do that.
Okay. Brilliant. Okay. All right. Okay. All right. Well, we better move on. I'm just looking at the time, and I know that some schools need to go by 12 o'clock. And so a lot of you have been asking some fantastic questions. And Danielle, I'm going to come back to you to moderate this and to kind of ask, if you don't mind, ask Maria, Aisling, and Prashati some of the questions that have come in the general sense. And then maybe Rob, he's been monitoring the breakout sessions. He can tell us about some of the great questions that were asked there. So Danielle, over to you.
All right, we just had one coming from Kleshkiran saying, how useful is AI with automating telescopes? Is there move to develop, is it currently being used? Oh, so is it being developed?
Okay.
Currently being used?
Maria, do you want to answer that one then?
I'm very happy to jump in here because at the European Southern Observatory, we actually do have a project at the moment, including AI in automating the telescopes. And specifically because we received a lot of observations which need to be taken at the perfect conditions. So the astronomer is not sitting, there is a service astronomer who does the observations, but the astronomer who will exploit the data is not always there. So we strive to do the observations which are needed for a specific science case in the best atmospheric conditions. And this is where AI can really help. At the moment, this work is done by humans. Once we have the ELT, problems will be more complicated. This is a very big telescope that the atmosphere influences in a very different way. So this is something that we are absolutely developing at the moment. We have a project ongoing in Chile together with local universities to do something called Astronomy 4.0, which involves AI into astronomy.
Very good. Excellent. Brilliant. Danielle, another one? Any other ones?
I have one here about Bertha. They were asking if students can control Bertha remotely. At the moment, no, we can't. It's a little bit tricky to have people controlling Bertha remotely. Technically, we could, but we don't have it set up that way because we have to kind of be on site to make sure that weather is good. So it could either be like, even if there's a slight drizzle in the air, we really can't open the dome, or even if it's too windy. So it would be a little bit too risky to be able to open Bertha up to be used remotely for classes, but we love of being able to do that. That is something we're thinking about for the future in some way. So keep out for that. I'm looking at one of the questions here. They're coming in so quickly. We are excited about we're excited about the telescope on the moon. How long do you think it will take before it is a reality? Also from Kleshkiran.
Okay, Maria, do you want to take that, or Prashati or Aisling? Maria, she's jumping in. Go on, tell us.
I'm more jumping in because of the question was already asked during my
in the breakout session.
That's why we've already had a brief discussion. So this is a follow-up question from Esa School. So it's going to take time. We first need to get to the moon. We need to get back to the moon. And I guess there Aisling would be more able to tell about ESA plans to get back to the moon, but it's not going to be in the near future. So we'll have to be patient, perhaps 20, 30 years, perhaps more. We'll first need to get used to build structures on another planet and or a celestial body, and this we haven't done yet. So it's super exciting times ahead.
Oh, imagine we'll have a telescope on the moon. That would be awesome. Awesome. Okay, brilliant. Any other great ones, Danielle, there?
Yeah, this is for everyone. What do you think we need to do to bring more women into astronomy?
That's a very good question. Very good question. Prashati, do you want to take a go at that?
Sure. Yeah, I think similar question was asked in our breakout room as well. I think one thing we should do is, uplift other women who are there and, inspire the next generation. If you see someone being there, you might want to be there as well in their seats. So I think, everyone who is here has been inspiring, others to do the same. And then I think for young men to support women and amplify their voice and bring them onto the tables that they are not at, and supporting them in that endeavor, I think is also very important. So I think that's what I would say is amplify and support.
Yeah. And Ashley, just women in space in general, like, would you like to comment about what we can do better to promote women in science and space, not even just space?
Yeah, I think this is one of the great things where we have a bunch of women showing how many different areas you can really dive into in all areas of STEM. And I think the work that's done by ESERO to really promote it at the school level, because I think that's, for me, that's where it has to be. It can't be at my age saying, oh yeah, we should have more women working here. It has to start at the school level so that there are people available, because I know a lot of people think, oh yeah, but it's only like making a quota up. But if you start at a primary school level and you make STEM available for everybody, then by 10 or 15 years time, it's an even playing field, and not everybody's interested in STEM. Maybe most of the people interested in STEM in 10 years are going to be female, or maybe they're going to be male, but at least if everybody has an equal access to it and an equal understanding that it can be something for them, then that's the way forward, really.
Yeah, I agree. Danielle, I'd say we time for maybe one more question, and then we're going to ask our panelists. Stephanie, do you want to jump in there?
I'll just jump in there just as a follow-on to Aisling, and I know I mentioned it earlier, but for students listening, I think a great idea is to get involved in the ESA competitions for schools, because that gives a great introduction to different types of science and technology. CANSAT is an engineering project, but obviously there's programming, there's soldering, there's various different types of STEM skills. AstroPi is very much a programming competition, but you need to do a project as well. And then I mentioned climate detectives is all about identifying a problem and using data. But the one thing about all those projects, as well as trying out different science and technology activities, is the soft skills that students develop by participating in extracurricular projects like that. Skills like problem solving, analyzing, working together as a team, communications, all the beautiful skills that employers are going to look for, whether you have an engineering degree or an astrophysics degree or whatever. Those are the types of skills that are really used right across all different types of careers. And a great way to do it is participating in extracurricular projects, not just the ESA ones, but in general.
Yeah, thanks, Stephanie. That's very valid. I think we have time for one more question, Danielle, and then maybe Stephanie, Prashati, Aisling, and Maria, you might head away into a breakout room and kind of judge what you felt throughout the whole morning, all your breakout sessions as well, that you believe was the best question. And Danielle and I can stay here. We can talk about creating our future, and maybe we can talk some more about how other people can get involved in Ireland in astronomy. So Danielle, last question before we get into that.
So if we have one from Holy Rosary, and this might be geared more towards Aisling, it looks like, but from your observations from lights so far, what do you think will be the next big step in the fight against climate change?
I think there's a huge amount going on already. Like with the Copernicus program that we are developing with the European Union, we are already flying, let me see, Sentinel-1, 2, and 3 are already in orbit. Sentinel-1 has actually just celebrated going beyond its original mission life. So its mission life was 7 years, and it's just gone beyond that. So, and it's still producing good data. So the Copernicus program is really looking at all aspects of the Earth in terms of not only just the climate, but so we're looking at things like the soil, like the salinity, like the oceans, the ocean levels. It's covering a huge range, and a huge amount of what we do in Earth observation at ESA is really trying to build knowledge for the general population to understand more about what's going on with the Earth. So we do things like we have images of the volcano in La Palma. We have images of lots of different things that you can see, and even things like one of our spacecraft, Sentinel-5P, actually had images from just before the pandemic and just after the pandemic started in terms of the pollution levels in cities like Beijing. And you can see a huge difference. And I think those kind of images, when general population actually get to see those, it kind of makes you think, hang on, this is what's going on, and this is what we can see in real time. So I think knowledge is power in terms of the fight against climate change that's out there. And Copernicus is generating like a terabit of data in a very short period of time. Like the storage of the data is huge. But the joy of ESA is that all of the data is free. So if you are a scientist or looking to understand more about that, any of the data that we generate from any spacecraft is completely free for member states. So anybody in Ireland can get access to that data and really use it to understand more and to make that next step in the fight. So yeah, it's all there.
Yeah, and it's really important work as well. Thanks, Aisling. Okay, I think it's time. I think we should, you guys need to go away and have a chat. I don't envy you because there was some great questions there. So Maria, Stephanie, Prashati and Aisling, and maybe Rob as well, because he was monitoring all the different discussions in the breakout session. Are you guys going to go to like a secret booth and have a chat about what you believe to be the winning question for the space goodies and the school? So Rob, what's going to happen? Are you all going to go into a breakout session?
We're all joining a short little breakout session.
Okay.
And we'll be right back to you.
All right. I'm going to leave you to do that. So let's just recap again about the Creating Our Future scheme, because it's kind of been a thread throughout the whole morning. Why is it important? Well, everything is about being curious. So what are you curious about? What are the questions that you have about the world around you? They don't necessarily have to be directly related to something science. Science is probably in there at some stage. What do you worry about? Do you worry about your grandparents? Do you worry about your animals? Do you worry about your community? Do you worry about climate? Do you worry about food? Do you worry about art? Do you worry about communities? What are the things that keep you awake at night? And what are those questions? And that's what Creating Our Future is about. It's a nationwide call, I think, because people want to know what you guys are thinking about, and what is the pulse of our country right now? What are the things that concern us? Because it's a smart thing to do, because if the government actually listens to us, then the things that we're going to be spending money on researching in 10 or 20 years time are going to be topics that you care about. And that's essentially what they're trying to do. So they formalized it, and they have, they're going around the country. They're setting up in different shopping centers across the city. There's like a whole kind of a tour, and you can join that. And you don't necessarily have to meet anybody. There's a website, creatingourfutures.ie, and you just go in there and you tell us what it is you're curious about. You don't have to have a big event. You don't have to tell anyone about it. It's nobody's business except you and hitting send on that button. And it gets listened to and it gets read. And the ones that are most interesting, or the ones that keep popping up, they're going to be put together. They're going to be proposed to a committee, and the committee then decide, this is how we're going to spend our money, our economy over the next 10 or 15 years to answer these questions that we as a nation care about. That's what Creating Our Future is about. So have a really good think. It's your chance to tell our government about the things that concern you, and it can be anything. So creatingourfuture.ie. So Danielle, let's have it, now that we've got a few minutes, let's talk further about how people in Ireland can get more involved in astronomy if they're interested in stargazing or the night skies. What would your advice be? Because I know you're a massive astronomer.
Yeah, I really wanted to follow up with some of the commentary from earlier, saying that it was creativity. That it was Maria that might have said it, that got her into it, even Prashati as well. Not creativity, curiosity. It was curiosity that got them into it. And
curiosity.
For me as well, it was going out into the night sky and looking up, and I was lucky that I got to go to a place outside of the city when I was younger. And we had a family cabin that we used to go out to where we were away from the light pollution. So I got to see the stars at night, and I got to see the Milky Way. And that got me thinking, and didn't know that was something you could actually get a job doing. So it wasn't until I got around who were working in the field and got into meeting other astronomers and going to events and conferences, I thought, oh my gosh, people do this for a living. They get to look at the night sky, and they get paid to do this. This is amazing. So it is that curiosity of going, what is out there? And when you're looking out, and this is what I love about astronomy, is you don't need to have instruments to do it. You don't have to have a telescope. You don't have to have binoculars. You can do it with your eyes to start, and just start looking at the constellations, start learning the sky. Notice how it moves. It's not the same every night, every time you go out. notice that the moon isn't the same every time you go out. So there are things you can do and then kind of work your way into it. I didn't look into a telescope until I was in my 30s. When was the first time you looked at it, Neve? Do you remember?
I think binoculars for me, we didn't have any, I didn't have access to any telescopes or anything, but binoculars for me is what like I always enjoyed bird watching and stuff. And then there was once or twice that I was in areas when I was living in Cork, I was out in the countryside, and there was just the whole night the whole sky would just light up. And I remember buying a book. I think sometimes it's good to get a book. Like I remember getting this book, one of those DK, the Dorling Kindersley ones. And it was like, I think it was like planets in the sun or something. And it had those charts at the back, and it kind of helped me understand what I was looking at. Sometimes it's like a book or a website, or I think the first time you see the moon through a telescope is, I don't think anything has ever come close to it. And only a few weeks ago, I was out with another group looking at the night sky. I never tire of seeing the moon through a telescope. I've never tired of it. Have you, Danielle?
No, and I'm telling you, I've looked at, you saw some of the pictures there, like the Ring Nebula. I've looked in the all different types of things in the night sky.
Yeah.
The moon is the one thing I always come back to. I never get sick of looking at it, and it always looks different every time, and I absolutely love it.
Yeah, it is lovely. So there you go. You've heard from everybody about like why they're passionate and why they're curious about space or astronomy. So have a think, and do visit creatingourfuture.ie. We know that you do have questions. They're curious about something, and we want to know what you're curious about. So what do you want our future to look like? So now is your chance to answer that. Okay, so I think our judges have returned. So the winning question is going to be announced shortly. So Maria, Ashling, Prashati, Rob, and Stephanie. I hope that wasn't too difficult. I'm glad I wasn't involved in that discussion. So Stephanie, I'll defer back to you, perhaps, to let us know who you think, who you all decided together the winning question was, and from which school. Tell us how.
Actually, I didn't keep note of it, so we'll have to defer back to Rob. But before we do that, we'll leave that as the last thing, just before, because we'll end out pretty quickly. Just thanks so much, everybody. Thank you to our three speakers. Thanks to Neve, and thanks to the team in BCO. Hope you to schools enjoyed it. The next event is on the 18th of November. It's a Science Week event. November. What did I say? November,
yeah, Science Week.
November, for Science Week, and their speakers are confirmed for that, and the details are on the ESERO.ie webpage. So over to you, Rob, to announce the winner.
Okay, so it was a very difficult decision because the questions were amazing, but the one that pinched it was a very philosophical question from St. Joseph's, asking why we might study solar eclipses and what we would hope to learn. So that was in Maria's breakout.
Oh, yeah.
You, well done. I'll be in touch about getting you your prize. And thanks again for joining us in the breakout.
That's lovely. Lovely. Great. That sounds great. What did they win, Rob? Tell us again what they won.
We have a space pack that has a European Space Agency hoodie. There is a NASA NASA pop socket, and there's a few other assorted space goodies from the BCO shop.
Nice.
A whole bunch of
very nice
toys and stuff that will send your way.
Lovely. Thank you. Well done. Very good. So that concludes our Space Careers Roadshow, the ESERO Ireland Space Careers Roadshow. Just like Stephanie said, these things don't just happen. It's a great team at BCO. Danielle and Rob and Alan and Stephanie pull this whole thing together. So they make my job very easy. So thank you guys. And as a special thanks to our speakers again today, to Maria Libanova, to Ashlyn Shannon, and to Prashati, and particularly Prashati for getting up so early. Thank you very much. It was a fascinating discussion, and it was about astronomy, and it was about women in space, but it was also about you thinking about how does this apply to you in your choices going forward, and look at the people that you have at your disposal, and never ever hesitate to ask a question or to reach out to anybody that you heard from today. They're all very passionate about helping you decide what your future is like. And take a look at that creatingourfuture.ie website. We really do want to hear, what do you think is important, and what kind of questions should we be looking at for our future? So that's it. Just to say, have a great day, and I hope you enjoyed the event, and please let us know and keep in touch, and we will see you again in November. So over and out.